So hi, and welcome to this speak by myself, Brian, and my friend and colleague, Thomas, who for the next small hour, we would like to answer the question of why we do event sourcing here in Lunar. And in this speak, we are also going to reach beyond event sourcing itself and have a broader focus on Lunar as a whole. After a short presentation of us, who we are, and what Lunar actually is, and it has already been mentioned, it's a bank, we will dive into how we have grown as a banking domain and as a consequence as an organization. We'll spend time on how we have been working with squads in Lunar, doing event-driven architecture and domain-driven design that together with event sourcing for us has been a really good match. So we'll try and put some context behind the one-liners that you can't predict the future, but you can plan for it. And first, you make the easy change. Then first you make change easy, and then you make the easy change.
But first off, who are we? I'd like to present my colleague, Brian. Brian has just had his 1-year anniversary in Lunar as lead architect. He joined Lunar from a position as lead architect in another Danish fintech company with more than 5 million monthly active users. Here he worked with domain-driven design and event-driven architectures for more than 6 years. So when he started at Lunar, he brought a lot to the table, and he is daily using this experience to evolve the Lunar architecture, but just as much the Lunar organization.
And I have the pleasure of presenting Thomas. Thomas has been in Lunar almost from the beginning. So he had his 5th year anniversary back in June this year. And as so many others of the first employees in Lunar, Thomas had absolutely no experience with fintech or banking. But he has been building distributed systems for various software companies for more than 15 years. So he is daily using his experience to build and to rebuild the Lunar banking core, which is currently in its iteration 3, in the squad that is named Orion.
Yeah, before we dive into the subject matter, let's give you all an idea about what Lunar is and where we are headed. We started out as a neobank on top of a real bank back in 2015. And from the very beginning, the aim has been to provide our users with a best-in-class experience and to challenge the traditional way of doing banking. And that's why it wasn't a problem that all of us didn't have any banking experience. We wanted to do it differently. Since the beginning of 2020, we've been operating as a bank ourselves with our own banking license and financial product offerings for both consumers and small businesses. The ultimate vision and goal for Lunar is to become a financial super app across the Nordics. The one place to go for everything having to do with your finances. No matter if you're a consumer or a business, and no matter if you're a student with simple financial requirements, or someone with a family and a house requiring loans and mortgage, or if you're a fast-growing business. Fulfilling this vision requires a new take on banking. Lunar is not like any other bank. We don't shy away from inviting partners into our ecosystem if they can provide value to our customers. And equally important, it also takes the courage to step into new territories and to try to redefine what banking is, doing what no one else has succeeded in doing before. So this journey to fulfill the mission has involved exponential growth across a number of dimensions. One such dimension is user intake, as seen on this graph, showing the accumulated user count from the very beginning. We've annotated this graph with key events in the Lunar history to provide you with some context for understanding the rest of the talk. So back in April 2016, we went live on a monolithic Rails backend. A few months later, we actually decided to start strangling the monolith and go the microservice way, which led to later in the same year, in September, squads were introduced in the organization to support the microservice architecture. And since we love space and are on a mission, they were named NASA, Gemini, and Mercury. On the platform side, Kubernetes was introduced in the beginning of 2017, and that's still a very crucial foundation for our ability to scale. But that's a completely different story, which you can find a lot of talks about out there. The first event source service went into production in the beginning of 2019. At this point, we knew we were going to build our own banking core. So this was a warm-up exercise born out of a hackathon project. And then in August 2019, we received our own banking license. After, and some months after, in the beginning of 2020, the first internal users were onboarded on our own event-sourced banking core. The key takeaway from this graph is that at the same time as we were building the Lunar organization, the tech stack, and the product offering, we also had to manage exponential growth in the user base. This growth posed both organizational and technical challenges, which we had to find solutions to. And at some point, we actually had to find a solution pretty fast, or the platform would break. In this way, our growth has been an important driver in the evolution of both tech stack and organization.
And talking about organization, the growing user base also required growing organization. So as Thomas said, we started back in 2015-16, and soon after we had 3 squads where Thomas was a part of it. Today we have 17 squads in technology, and we are still growing. And currently, all in Lunar, we number more than 270 employees. It has almost been a doubling every year, and only within the last 12 months we have onboarded more than 200 new colleagues. But this wasn't just due to increased user intake. It has just as much been due to domain complexity and domain expansion. So we started out in Denmark, but soon after having rebuilt the core and first version, we added Lunar Bank into new markets outside Denmark, into Norway, into Sweden. Then we added Lunar for businesses, small companies. And this year we added and acquired Lendify in Sweden to add advanced lending and credit facilities to Lunar. So the key message here is that we also experienced accelerated growth in the organization due to domain expansion. And with that many engineers, technologists, we also produce a heck of a lot of code. So long gone is the time when you as an engineer could just contain everything in your mind about what's going on in Lunar. The cognitive load is way too high based on the sheer amount of code. We today have more than 200 microservices in Lunar and more than 480 repositories in our catalog. So the catalog we'll return back to a little later. We use backstage.io. And the observation we did was that increasing user base, of course, gives more outlier cases. We introduced more countries, but also more segments adopting a use segment. As we introduced businesses, we also added to the number of challenges we have. So it's not only native app, Android and iOS, but now it's also web, as businesses require this interaction. And we have, as stated on the previous slide, more advanced products with lending and credit, buy now, pay later offerings, or crowd lending. So we needed to do something. And that something, our answer at least, is to take the inspiration from domain-driven design, setting boundaries based on our business products, based on our domains, and based on our user journeys. And from team topologies, take inspiration to classify our squads, which the next slide will tell you more about. So here the main point is that we really took steps to decrease the cognitive load for engineers in the individual squads. And what is then a squad? Well, in Lunar, we organize around squads. And I suppose, again, this is due to the space theme you will recognize everywhere in Lunar. Other places you might say this is a team. It's a group of people having responsible for one or more of our business domains. In this case, in the example, it's the lending and credits domain with the squad Artemis. And their mission as a squad is to support our users in borrowing money in an easy and quick fashion. So we prefer to make these squads really domain-centric and with a deep product insight. We want them to take a 360-degree responsibility for the product and for the user aspect. Here it's lending. And this also requires them to think about the operational impact. The key metrics, if they produce a product that is not fully up to snuff, how will this impact our front office, our bank office, the revenue that we make in the bank? The reason for this is that we really want to ensure that within the squad, there's a full understanding of the reasoning, the business reasoning behind every change, every requirement that they are asked to make.
Squad Artemis is an example of a product squad inspired by the stream-aligned team in team topologies phrases. As Brian just said, the product squad has a very specific mission and caters for a specific user group. And it must solve problems for this user group as fast as possible. In this case, the user group is external customers, that is the actual users of the Lunar Bank. However, we also have squads of the other types. For example, Squad NASA, who is our platform squad and has been there from the beginning. They have all the other squads as their end user group. Squad Orion, which I'm in myself, is both a stream-aligned team covering the payments domain, but also abstracts away the complications of the national clearing. And in this sense, it's a complicated subsystem team. But for all types of squads, we want them to work with fast feedback loops. This requires the squads to be in a constant dialogue with their end users. For product squads, this is typically achieved by having dedicated people from the product team as part of the squad. And speed is supported by having squads populated with all the needed skill sets, full stack where that is required.
So now, being familiar with the concept of a single squad, let's zoom out and set a perspective on our organizational growth, adding in geography, or as we call it here, technology hubs. So here we actually believe that we have succeeded and are trying to still succeed with an inverse Conway maneuver as we evolved over time. So as the business domain expanded and complexity grew across the markets, we have created organizational structures around the squads and hence around the domains. So as mentioned, we started out, and this was in Aarhus, Jutland, Denmark, with a few squads on a simple consumer banking domain. Over time, we enhanced the banking areas. We expanded the consumer domains with investment, we added business customer specific domains for that target group, and we really set focus on our platform development, our cloud operations. So we in parallel added to the number of people, to the number of squads. And getting own banking license meant that requirements grew for the banking operations. Reporting and data. We established 4 squads in Copenhagen with these specific domains as their responsibility. And then we actually moved data, the organization around data, front office support, back office, organization from Aarhus into Copenhagen, building up and supporting the organization out of that hub. And this supports another principle, that we prefer to have strongly coherent domains placed together, and if possible, we want them placed in the same hub. So when we then in this year added Lendify to our family, of course we also established the organization of lending and credit around our Stockholm hub. So the key message here is that we really want to build Squad around the architecture, the domain architecture that we want, and we want to support this with organization and physical location where possible. And then having established that we have squads, the squads have missions, and we are building an organization that supports these missions across these 3 geographical locations. How then to distill these missions for the squads? So for this we did and continues to do context mapping and context distillation. And I guess many of you perhaps know Nick June. So thank you for inspiring us, for having the dimension of business differentiation and complexity onto our domains. Really helping us to determine, as Thomas mentioned in the beginning, that even though we are a bank and move customers' money every day, we as Lunar Engineering do not need to develop and maintain everything ourselves. So back in 2020, when we did this mapping exercise, and sorry for the very busy slide, this really helped us to clarify the domain importance for various domains. We determined that we will happily outsource traditional banking areas like connectivity to the clearing systems. We do not need to develop FSA reporting, tax reporting systems. Happily outsource that. We don't need to develop and maintain liquidity management systems within the bank, or for that matter, document distribution systems that are national to the country where we are in. We should focus on where we can make a difference for our customers. This is in the everyday journeys. It could be for customer card management or benefits, payments, actual interaction with the customers, personal financial management, and money movement journeys. So another valuable insight that was gained was in the area, and this is just an example, for investment, which at this point in time was generic. So this actually was placed, and you perhaps can't see it, but it's the red dot up there. It's placed pretty close to our core. Hence, it's an area where we in the future, which is now, should strengthen our own squad and domain insights. And this is actually what we have done, having the squad Apollo focusing in on this area. So the key message here is that we believe domain distillation helps us to focus and ensure that business differentiation and complexity knows where we can put effort behind core in Lunar. But knowing the squad's mission and where to put the effort can still pose problems for us. So especially if many user needs or business requirements present themselves at the same time. And as we have hypergrowth, you can probably imagine that, yes, this can happen. So the following example will speak a little bit into this, taking one single domain where we know that this is very core to us, our users. So here we have the user domain, and it's Squad Mercury. That's the responsible squad. And this is originally one of the very first microservices. And over time, this has actually grown a bit into a microservice, which, it happens over time. So this actually has become a bottleneck for speed and growth. But by doing event storming and really focusing in on the domain language inside the domain, we established that having just one user aggregate wasn't sufficient. We needed to split users into users and customers, distinguishing between those fully onboarded with accounts and those without accounts in Lunar. And this really made a lot of sense. We also realized that identity is a separate aggregate, that can work across several users and several customers. And this is very important for us to continue doing domain refactoring as an exercise in our squads. We strive in every squad to have a sort of 60-20-20 ratio. So this is 60% effort spent on really doing changes for the bank. Then 20% effort on keeping us operational, running the bank, fixing immediate problems, and then the last 20% for improving and ensuring that we can continue to refactor our domain. Then, as complexity grew and we expanded the domain, as mentioned, with business customers that can both be single owners and have multiple owners, they can have employees and co-workers, the cognitive load was maxing out and we needed a decision. So after having discussed this with the squad, it was decided to do a scale up, scale out. This is also known, I think, as absorb and split. And the squad Mercury was split into two, and squad Calypso was established, which now has the responsibilities for companies and co-workers, and soon to add third-party users like accountants. So the key message here is that the focus on the ubiquitous language helps us to distill the meaning out of a single domain-bounded context. And if we need it, and if the complexity increases, we can scale our organization, for instance, as this example, by doing a scale up and a scale out.
So as Brian has shown, Lunar's growth has been a challenge at the organizational level and required us to constantly improve our understanding of our own domains and the way our squads are structured around these domains. Let's now have a look at how the organizational challenges of the squads translate directly into the inherent challenges in a microservice architecture. So in Lunar, a single squad is not capable of fulfilling its mission on its own. Although a squad works inside its own domain, it must communicate with the domains of other squads to fulfill its mission. For example, the user domain, which Brian mentioned as a case, lots of other squads need to communicate and interact with the user domain. And it's extremely important that the communication is consistent. A squad must have a consistent view of the other squad's domain. Likewise, a squad should be able to cause changes inside the domain of another squad. And these changes should be guaranteed to take effect. So summing up, we want our domains to be independent, but able to share information consistently, and decoupled, but able to cause changes with guarantees. So how does this translate into a microservice architecture? Well, just like for a squad or a domain, and even more so, a microservice is not on its own. It requires other microservices to achieve its goal. But microservices are isolated units in terms of transactional boundaries. So the characteristics of our domains translate into two fundamental questions in a microservice architecture. How should service A get access to and use information from an upstream service in a consistent way? And how should service A execute a side effect in a downstream service B with the same set of guarantees as if it was in the same transactional scope? So let's address the first question first, the one about consistent communication. How does service A access and use information from the domain of an upstream service B? Back 5 years ago, when we started our microservice journey, we made a choice in relation to sharing of information. And this choice was from the very beginning guided by the autonomous squad as the fundamental organizational unit. So we wanted to empower our squads to iterate fast on new features, and to do that, they should be able to build on information from upstream services without disturbing the owning squad. That's why we, from the very beginning, agreed on the phrase, we prefer messages over RPC. Consequently, our architecture has from the beginning been event-driven. All business events are published as integration events in a pops-up manner. This allows squads to build new functionality based on existing upstream events in an autonomous way without involving the upstream squad. Furthermore, integration events are expressed in the ubiquitous language of the domain. We call it events on the outside to distinguish it from the internal domain events of an event source system. Additionally, our streams of events on the outside borrow some characteristics from the internal event streams of event sourcing. They are partitioned by identity ID, typically an aggregate ID, into ordered substreams. And this ordering allows downstream services to reason about incoming events relating to an entity. Is this event a replay of an event I already did consume? If yes, then just throw the event away. And by subscribing to upstream events, a downstream service in another domain is in this way allowed to create eventually consistent views of the upstream domain. Or an upstream event may cause some action to be taken in the downstream service. For example, if a user owning a business is closed, well, then the company service may remove the user as owner of the company aggregate. Of course, this does not come without its own set of challenges that needs to be addressed. As we have grown and new services are spawned at a constantly increasing speed, bootstrapping of new services with upstream data has become a frequent problem. Up until recently, this was something which each producing service had to implement on their own. However, we have just recently implemented a general reconciliation mechanism. So for new services, it's more or less a one-click action to do reconstitution of upstream events. And having said reconstitution, you also need to be very strict about idempotency on the receiving side. The read models must be idempotent in order to build a consistent read model. Likewise, for the actions taken based on upstream events. So now let's talk about the second question. How do we make sure that a side effect is guaranteed to be executed in a downstream service? This question is fundamentally just the question of how to do two commits across transactional boundaries. When the commit is done inside the boundary of service A, we want to be guaranteed that the derived effect is executed in service D in this case. So let's revisit the question in the setting of traditional CRUD service. How would you guarantee the execution of a side effect after an update of the state in the database? Typically, this is implemented using an outbox pattern, where the fact that something changed is written to an outbox in the same transaction as the actual change. And the outbox may then be polled for changes for which the side effect needs to be executed. Using event sourcing as persistent model makes implementing this outbox pattern somewhat easier. Why? Well, you almost get your outbox for free. The only thing we persist in an event sourced model is the changes. Hence, we just have to need to do a small addition to the database to keep track of which of the events in the event source for which we have applied the side effects. This feature has been built into our event sourcing framework. We call it guaranteed event handling, and it is essentially an observer pattern with a subscription mechanism, where Handlers may subscribe to event streams and are then guaranteed to be given all events in order. The guarantee on ordering is not global, but for a specific event stream instance, for example, a specific account, handlers are guaranteed to get all events in the correct order. This is a very crucial feature of our platform, and it's the fundamental feature on which our banking core is built. Without this, payments would be lost in intermediate states, users would not see transactions posted on their accounts, etc. The use cases of the feature are everywhere in the platform. We use it internally in a service to update internal read models and to guarantee the publication of the integration events. We use it to implement sagas, process managers, and to execute side effects in other services or third-party integrations. As in the previous slide about events on the outside, guaranteeing execution of side effects comes with its own set of challenges. A major one is, of course, idempotency. The side effects caused by the handlers must be idempotent to cope with more than once delivery of an event. Well, we have learned that inside our own platform, this is possible to deal with. It's simply a fact that all squads are aware of. Command APIs must be idempotent, and likewise for event handlers updating read models. However, if the side effect is in a third-party integration, you rely on the third party's implementation of idempotency. And unfortunately, not all of our integration partners live up to this. So once in a while, we encounter support cases due to idempotency issues. This is something that we handle case by case, and often squads have to build mission control endpoints to remedy the effect of broken idempotency. Another challenge is replay of internal domain events. If, for example, adding a new internal read model, you must be able to replay all the internal events in order to hydrate this read model. In the Lunar platform, we haven't yet implemented a good generic way of doing this. It's something we're looking into as an improvement of the platform in the near future. So, as shown in the previous two slides, our event-driven architecture has come with a number of challenges that we've had to solve. Also, event sourcing as persistence technology in itself comes with challenges we've had to address. One such challenge was guaranteed event handling, which is very crucial. Another challenge we learned the hard way was related to long-running aggregates. So now our platform, we use event sourcing for all kinds of aggregates. Short-running aggregates like payment with a life cycle measured in days. Long-running aggregates like a user or an account with a life cycle measured in months or hopefully years. Brian, will you click? For long-running aggregates with a lot of events, like the account, we learned the hard way that generating the aggregate state from a long stream of events will become a performance bottleneck at some point, simply due to loading the events from the database. If anyone in here heard Oscar's talk earlier today about building the worst event sourcing system ever, this was exactly what he talked about. Long event streams will cause heavy I/O load on the database when loading the state. So the graph I'll show you now should be no surprise. It shows the evolution of the fractals of load times of the account aggregate over just 2 weeks in the summer of 2020. Can anyone guess what it would look like? Well, it's here. No surprise. For the most busy of our users, the time it took to load the aggregate started to increase exponentially. That's quite a problem since we have to answer the card network pretty fast when a card reservation is authorized. So we knew we had to do something about this pretty quickly. And the solution was to implement snapshots into the platform. well, actually, the first solution was to scale the database, but that only gave us a few weeks of runtime. We implemented snapshots, and the next graph shows the result of this. Instead of load times being proportional to the number of events, we now have constant load times due to the snapshot. So the drastic dip in load times were when we enable snapshots in production. So a number of learnings can be extracted from this. First of all, you have to expect surprises. Getting things into production will always come with surprises, things you hadn't thought of, or things going wrong much quicker than you could imagine. But on the other hand, don't try to implement everything from the very beginning. We've tried to do what we call just-in-time development. It's okay to go into production with something which is not completely finished, as long as you're prepared to throw everything else away when it starts burning. The addition of snapshots to long-running aggregates was an example of this. But even the snapshotting mechanism is not done yet. We still have to solve the challenge of preheating snapshots when the aggregate state model is updated. And finally, in order to do this just-in-time development, you need to have metrics in place. You need to be able to monitor your system in detail to pinpoint exactly where the problem is.
So to sum it up in a simplified view, some of the considerations and implementations that we have done here in Lunar over the recent years. Our domains receive commands from clients and puts this into the event source, appending to an aggregate root or reading from a view read model, where we use the command query responsibility segregation pattern. We have insisted on integration events to be published over Rapid because they're relevant on the outside of your domain boundary. We have implemented guaranteed event handling on the inside to ensure integrity of data. We have optimized with snapshotting for performance, and we have focused on the idempotency as a requirement for all of our squads. We have implemented guaranteed event delivery for data integrity between the domains, and we have implemented replay to foster both domain expansion or quick domain repair. We have implemented reconstitution to further ensure data integrity and eventual consistency across the entirety of our domain. As Thomas mentioned, we are using this just-in-time approach, so internal domain replay is not yet something that we support, but we'll get there. We've only lightly touched upon areas like sagas, error queues, service discoverability, but to deep dive on those areas, we'll have to wait to another session, because all of the things we have done here is to, including the way we do event source persistence, is to foster and promote the scale of development across many squads. So we mentioned earlier that we use backstage in Lunar, and now we want to put a few words on why. So we do this to have a place for our best practices when we onboard new engineers. We do this to have a service catalog for well-documented services. We do this to have a place where we can manage and monitor our error queues. We do this so we have a place where we can have API discoverability and documentation. And then lately, we do this because we want to manage and trigger quick replay and quick reconstitution. So what we try in Lunar is to make it very, very easy to replay and reconstitute, expanding, as you have seen, the need for the current domain with new services. This could be specific read models, like optimizing for calculating limits on an account, or expanding a new domain, bootstrapping company owners from the user example from the original user's domain. And this caters for parallel squad development. As we encourage inner sourcing in every squad, a squad can make a pull request for a new view model independently of the owning domain squad. The owning domain squad will then, of course, have to do review before this can be released into production. Or a squad can create a completely new domain model from scratch based on the original events and have that up and running in a matter of minutes, taking the full responsibility then for this new domain model. So this brings us to the conclusion that now we hope that the takeaways you'll take here is that we have explained why we do event sourcing in Lunar. We have shared some of the learnings along the way, that event sourcing is just one technique we use. We have talked about how squads play a vital role in Lunar, and doing event-driven architecture and domain-driven design is key to support the hypergrowth, both regarding load on systems, but just as much the rapid scale of our organization, the expansion of our squads. So with learnings from and inspiration from team topology and domain-driven design, we have a focus on squad missions to match user domain needs. We expect this rapid growth to continue throughout the next years. So we'll continue the hockey stick, both for user intake, product utilization, but furthermore, we expect to continue adding more engineers, doing more scale up, more scale out, going from the 17 squads we have today to past 20 squads, as we are still expanding our banking domain. New mergers are actually in the horizon. So hopefully this has shown why the quote, "You can't predict the future, but you can plan for it," is vital to us. And with event sourcing, this is what we do here in Lunar. But just as important, or maybe even more so,
is Kent Beck's famous quote, "Make the change easy, then make the easy change." This quote is probably well known to most of you, at least if you attended DDD Europe last year. You'll know it since it played a central role in his keynote at the conference, and so central that DDD Europe made this nice sticker out of it in just 24 hours. An example of just-in-time development, I guess. Kent Beck originally coined this phrase in the context of code changes and refactoring. But we think that it also applies at higher levels in the tech stack and also in the organization. It's all about making it easy to implement a change. Much of what we have been doing in Lunar in order to enable the success of an organization centered around the autonomous squad can actually be seen as an application of this quote by Kent Beck. At the organizational level, we try to make it as easy as possible for the squads to succeed on their mission. We do that by empowering the squads with all the required skills to succeed, and by reducing friction by organizing the squads coherently around the domains. Likewise, at the technical level, we try to implement an architecture, a platform, and developer tooling to make it as easy as possible for the squad to be successful. As you cannot predict the future, we have focused on making it as easy as ever possible to adapt to any change coming. And with these two quotes, we end our talk.